Hello guys, and welcome back with Mrs. Struble. Today we're going to be talking about how to factor expressions. Now when we factor expressions, what we're really doing is we're just rewriting them as a product of factors. What that means is we're rewriting them into a multiplication problem. So just for a simple example, we're taking, for example, like 25, and we're saying how can we rewrite this into a multiplication problem? 5 times 5, okay? But we're doing that with algebraic expressions now. So expressions that have variables or unknown numbers. And we're going to use the distributive property in order to do this, because the distributive property is what we use to simplify these expressions. It only makes sense to use it to undo that simplifying. Okay? So let's take a look at an example. First up, factoring out using the greatest common factor, or the GCF. In order to do this, first we can create a list of factors for each term. Okay, so we have 16x and positive 12. Each of those are terms, and they are not like terms. Let's find the factors of these. In other words, how can I get 16 using multiplication? Well, I can have 1 times 16. That's the most obvious, right? But then we also have 2 times 8 and 4 times 4. All those numbers that we just listed, those are the factors of 16. Okay? So when we list them out in a nice manner, we have 1, 2, 4, 8, 16. But then we also have x, because x is part of that term. Now let's do the same thing with 12. Well, let's see. We can always use 1. Can I take 2 divided by 12? Oh, sure. 12 divided by 2? Yep. 2 is one of them. Is 12 divisible by 3? Yep. And in fact, 3 times 4 equals 12. 2 times 6 equals 12, and then 1 times 12 equals 12. So these are the list of factors of 12, and each of them have a little pair, a pair. That's how we get 12 using multiplication. Okay. Now to find the greatest common factor, we're looking at these lists and we're identifying the number that's the largest in both of these. In this example, it's 4. 4 is in both 6x and 12. What that means is when we are factoring this expression, we're going to pull out a 4 or divide both terms by 4. So once again, we have 16x plus 12. We have found out that the greatest common factor is 4. That's the biggest number that we can divide them both by. So we're going to take that out. So 16x divided by 4, what's left? Whatever's left is going to go into our parentheses here. Okay? And we're recreating what we would have undone when simplifying these using the distributive property. So we would have 4x here, and then 12 divided by 4 would be 3. Okay? These are, in order to check, make sure we got it right, we just do 4, we use the distributive property. So 4 times 4x, yep, that's 16x. 4 times 3, yep, that's 12. Okay, so this right here is our factor of 16x plus 12. Okay, that's how we factor it out. So our final answer, let me clean this up a little bit. Our final answer would be 4 times 4x plus 3. Okay, let's do another one, but this time we're going to work with a rational number, a fraction. Okay. So factoring rational numbers now. We're given an expression, 1/3 x plus 5/3, and we need to factor out the 1/3. Again, when we factor, we're dividing each term by that factor. Okay? So we're taking 1/3 x, dividing that by 1/3. We're taking 5/3 and dividing it by 1/3. We're pulling out that 1/3 product or factor, okay? And we're identifying what's remaining or what's left in that problem after we do that. So 1/3 x divided by 1/3, well, any number divide by itself. So 1/3 dividing by 1/3, that's going to equal 1. So all that we have left in that first term is x. Now let's do the second term. 5/3 divided by 1/3. We're dividing fractions, so we need to keep, change, flip. 5/3 stays the same. We're going to multiply by 3/1. We notice that there's a 3 in the numerator and the denominator, so that reduces and cancels out to 1. And now we just multiply straight across. 5 times 1 is 5. 1 times 1 is 1. The answer is 5. Okay. So what is left after we take out or factor 1/3? After we have factored 1/3, we get x plus 5. So this is considered our factor of 1/3 x plus 5/3. Okay. Let's try one more. This time we're going to use a negative number. And I'm not telling you what to factor by now. So you have to make a decision. When it just says plain old factor, that means, hey, you have to determine what you're going to factor. If it asks you to factor using the greatest common factor, then you need to find the greatest common factor. You need to figure out what's the biggest number you can divide both of them by. If we have negative 10g and a positive 25, we want to factor out a number that can divide both of them by. And right away we see 5. Do you see it? Both of these can be divided by 5. However, there's this little negative in front of the first term. Okay, the first term is actually negative here. So we're going to take out that too, just for this example. We're going to take out the negative. Okay? So if we were to factor this using a negative 5, what would be left? Negative 10 divided by, negative 10g divided by negative 5. Well, 10 divided by 5 is 2. And then we have a negative and a negative. So a negative divided by a negative is going to be a positive. Okay? So it's just 2, and then g tags along. G's still there. We didn't touch him. Now what about the 25? We have 25 divided by negative 5. Again, we have a positive divided by a negative, so that's going to equal a negative. And then 25 divided by 5, 5. Once we have factored, we get this expression. Negative 5 times the quantity 2g minus 5. Okay? All right, so in this video, we were working with factoring expressions. Hopefully it's helped you out a little bit. Till next time, this is Mrs. Struble with Struble Math. See ya.